so in the direction of x cap. So here we can find the required vector with the magnitude 3 in the same direction. So we just need to multiply the unit vector with the required magnitude. And if we want to find the magnitude, for example magnitude of 4 in the opposite direction of x, then we just need to multiply x cap with the required magnitude, but with the sign minus. For example, if we need to find vector with magnitude 4 in opposite direction, of x, then we just need to multiply a unit vector with 4. This represent the vector with magnitude 4 in the direction of x, but we need the vector with magnitude 4 in the opposite direction of x. So here we need to sign minus, which represent the opposite direction of x. So we just need to multiply it minus 4 here with minus 4, 5 upon root 30 minus 2 upon root 30 and 1 upon root 30. So it is equal to minus 20 upon root 30, 8 upon root 30 and minus 4 upon root 30, which represent the vector which have the magnitude 4 and the direction is opposite to x. So using one example we can find many things using the modulus of the given vector. This is the most important example from the vector side, and in the exams this kind of example frequently asked. Next, if we look at the PPT, then the next thing in this chapter is very most important is dot product of any two vectors. Just look at the definition of dot product is v. If v and w are two vectors, then v dot w is defined as a1 a2 plus b1 b2, where v is equal to a1i plus b1j and w is equal to a2i plus b2j. So v dot w is equal to a1 a2 plus b1 b2. Here note that v dot w, v and w are vectors, but v dot w is not a vector, it is a scalar. So dot product of any two vectors is a scalar. So by this method we can find the dot product of any two vectors v and w. So let us look at a small example to understand this formula. If v is equal to minus 2i plus 5j and w is equal to 4i plus j, then if we want to find v dot w, then v dot w is equal to minus 2 into 4, which is the coefficients of I, and then plus 5 into 1, which are the coefficients of j in v and w. Here minus 2 with minus 4 plus 5 with 1. So after all we will get minus 8 plus 5 is equal to minus 3. So v dot w is equal to minus 3. Note that minus 3 is a scalar, not a vector. So this is the dot product of any two vectors. Note that answer is just a number, not a vector. That means answer is a scalar, not a vector. Useness of dot product. So the dot product is useful to find several things. One of the important use is in a formula to finding the angle between two vectors, for example a and b. Okay, so if u and v are two non-zero vectors, then the angle, if we take the angle between u and v is theta, then we can say that geometrically cos theta is equal to u dot v upon modulus of u into modulus of v. So from this formula we can find the angle between u and v using u dot v and modulus of u and modulus of v. So here this is the direction of u and direction of v. There is an angle between u and v. So technically there are two angles between this vector, one going the shortest way and one going around the other way. We are talking about the smaller of that two, so which is 0 less or equal to theta less than pi. Let us look at one example to find the angle between two vectors. U is equal to 2i minus j and v is equal to 4i plus 3j. Here this is vector u and v. Here the angle I have look at the angle theta which is between u and v. So here first our formula cos theta is equal to u dot v upon modulus of u and to modulus of v. So here first we need to find u dot v, then modulus of u, then modulus of v, then we can find the angle cos theta, then we can find cos theta, and after that theta. Okay, so here u dot v is equal to 2 into 4 plus minus 1 into 3 as we have discussed above. So this is equal to 5, u dot v is equal to 5 here, right? So and modulus of v is u is equal to in root 2 square plus minus 1 square is equal to root 5, and modulus of v is equal to in root 4 square plus 3 square is equal to root 25 is equal to 5. So now cos theta is equal to u dot v upon modulus of u into modulus of v. So u dot v is equal to 5 upon modulus of u is equal to root 5 and modulus of v is equal to 5. So cos theta is equal to, after all, 1 upon root 5. So theta is equal to cos inverse 1 upon root 5, which is equal to approximately equal to 63.4 degree. Okay, so using the dot product of any two vectors we can find the angle between these vector very quickly using the dot product. Okay, so this is the another example to find the angle between the vectors v is equal to 3i plus 2j and w is equal to 6i plus 4j. So here v dot w is equal to 6 into 3 is equal to 18 plus 2 into 4 is equal to 8, that is 18 plus 8, that is v dot w, and modulus of v is equal to in root 3 square means 9 plus 4 is equal to 13, and w modulus of w is equal to in root 6 square is equal to 36 plus 4 square is equal to 16. 36 plus 16 is equal to 52. So here cos theta is equal to 26 upon root 676 is equal to 1. So theta is equal to cos inverse 1 is equal to 0. What does it mean when the angle between the vectors is 0? Let us look here. Here the direction of both the vectors 3i plus 2j and 6i plus 4j are equal, so there is angle 0. So the vectors have the same direction. We can say that the vector have the same direction if the angle between two vectors is 0. Then both vectors are parallel, because remember that vectors can be moved around as long as you don't change the magnitude or direction. Okay, next very most important thing is, if the angle between two vectors is pi by 2, then what would that dot product be? So this is the very most important question, that what is the dot product of two vectors when the angle between that two vectors is pi by 2. Here cos theta is equal to u dot v upon modulus of u into modulus of v if the angle is pi by 2, then cos pi by 2 is equal to 0. So if we put cos theta is equal to 0, then u dot v upon modulus of u into modulus of v is equal to 0. So after all, u dot v is equal to 0. Okay, since cos pi by 2 is equal to 0, the dot product must be 0. Okay, so vectors u and v in this case are called orthogonal vectors. Okay, so if we want to prove that any two vectors are orthogonal to each other, then we just need to prove that the dot product of that two vectors is equal to 0. Let us look at one example that determine whether the vectors 4i minus j and 2i plus 8j are orthogonal or not. First we need to find the dot product and see if it is 0 or not. Here v dot w is equal to 4 into 2 plus minus 1 into 8 is equal to 0. That means v dot w is equal to 0. So the vectors v and w are orthogonal to each other. Okay, so using this we can ask we will take one more example related to dot product. If we take practically, then for example, if we ask that for what value of p the vectors 2i plus 3j minus k and pi minus j plus 3k are orthogonal to each other. Okay, here we ask that for what value of p these two vectors are orthogonal. So we know that let us take a is equal to here 2i plus 3j minus k, that is equal to 2 3 minus 1, and b is equal to pi minus j plus 3k, that is equal to p minus 1 and 3. And for what value of p these two vectors a and b are orthogonal to each other. So we know that if these vectors are orthogonal to each other, then a dot b must be equal to 0. Okay, so we will take here 2 3 minus 1 dot p minus 1 3 is equal to 0, implies this is equal to 2p. Okay, 2p minus 3 is equal to 0. Here 2 with 3, then 3 with minus 1, then minus 1 with 3. So 2p minus 3 is equal to 0, implies 2p minus 6 is equal to 0, implies we will quickly get p is equal to 3. So using this property that if two vectors are orthogonal to each other, then their dot product must be equal to 0, we can find the value of p using this property of vectors. So this is a very most important method related to which there are mostly example asked in exams of GTU. Here let us look at the application of the dot product, then use of the dot product to find the work done by a constant force F in moving an object from A to B. So if we want to find the work done, then we just need the vector F and the displacement AB of any object which is moving from the point A to point B. Then if we want to find the work done, W is equal to F dot AB. So we just need to find dot product of force and the displacement. Okay, so let us look at the example in which we will try to find the work done by the forces. Okay, let us look at one more example. Here, if we want to, here the example is, a question is, a particle moves from the point A 3i, that is 3 minus 2 1 2, to the point B 1 3 minus 4. Under the effect of the forces, F1 is equal to 1 minus 1 1, F2 is equal to 1 1 minus 3, and F3 is equal to 4 5 minus 6. A particle is moving from this point to this point under the effect of these three forces, F1, F2 and F3, and we need to find the work done. Find work done. Okay, so first we need to find the total force F, which is equal to F1 plus F2 plus F3. So adding these three vectors very quickly, we will get 4 plus 1 plus 1 is equal to 6. Here 5 plus 1 minus 1 is equal to 5, and then minus 6 minus 3 minus 9 plus 1 is equal to minus 8. Okay, so here F is equal to, total force is equal to 6 5 minus 8, and here point is, a particle is moving from A to B. So if we want to find the displacement AB, and AB is equal to OB minus OA, which is equal to 1 3 minus 4 minus 3 minus 2 1. This is the simple subtraction of two vectors. Then it is equal to 1 minus 3 is equal to minus 2, 3 minus minus 2, which is equal to 3 plus 2 is equal to 5.